In this examples here, we'll try to solve. This is a general type of questions, problems related to the motions of particles passing through the electric field on a capacitor plate. And in these problems, the given data are the length of the plates, the distance between plates, and the potential difference between the two plates. The other part that can be given was the electric field E, or the speed of the electrons, or the distance, etc. But let's focus on these basic questions here, and with the 5 different types of question that can be deduced from the given data. So we have an electron entering the capacitor plates, and so the length is 70.5 millimeters. The distance between plates 45 millimeters. The potential difference 125 volts. So question number one: what is the accelerations? Of course, on the y direction, because we are not have anything change from the x direction. And then the number to calculate the total time. So we are calculating the total time for the electron to travel the whole length of the capacitor. Just to remember that the Tx should be the same as Ty. How far from the horizontal the electron is leaving the plates. So I'm going to make a sketch later on. So if we're talking about the horizontal x here, so the electrons is moving up, and what is this distance here? And number 4, what is the velocity of the electron when it is leaving the plates? So that's a Vy final. And calculate the velocity direction angle. Since the Vy is going up, the Vx is going horizontally this way. So the question is, what is this angle here? So if you have to solve for an angle. Okay, so let's start from drawing a sketch of these problems. So we would have the plates here. Let's put positive charge on the top, negative charge on the bottom. So what happened is, let's say this is our, for example, let's draw this. This is our electrons, and this gonna enter in this direction, the plates, the capacitors. And since we know that an electron has a negative charge, so there is a force between the positive and negative here. So there is an attraction. Electron is moving up. So let's draw it in this direction. It's leaving on this side. So the question is, what is the acceleration of the electrons? Question number 2, determine the total time for the electron to travel this direction here. So to go from, let's say, point A to point B, what is this time here? Question number 3, how far from the horizontal the electron is leaving the plates? So that would be this, so let's call this H, and H is here. Here is horizontal, so the electron is leaving there. So what is H here? The next question is number 4. What is the velocity of the electron when it is leaving the plate? So it has a vertical velocity. So let's say we have this as a vy, and the very last question is what is the velocity direction angle when you combine the Vx and the Vy. So that would be, if I draw just a big rectangle here. So here is the initial velocity. This is the Vy in this direction. So we are looking for this vector here. And the angle, let's call this the angle theta right there. So again, this direction is Vx, this direction is a Vy, and we are looking for the angle, alpha. So let's call this theta, I mean angle theta, which is right there. Okay, so that's the basically the problem. So we're gonna solve one at a time. I will go very quickly because once the basics is again doing the sketch here. So we're gonna solve question number 1 about the acceleration. So what is the acceleration of the electrons? We apply, we're going to use again from the mechanics, the second law of Newton, F equals ma. And from here we can say that A equals F over m. F is the force applied to the electrons moving inside the electric field, and m is the mass of the electrons. Now, particularly in this type of questions, we can also express that A is Q. Q is the charge of the particles times E, electric field, divided by mass of the electrons of the object. But at the same time, since we are not given the electric field, we can also use A equals QV. Q is again the charge, V is the potential difference between the plates, and we divide it by m over d. This is the distance between the plates. So this is basically the equation that you're going to use in this case. So Q is the charge of an electron. So the charge of the electrons is 1.02. You can find it in the textbook, minus 19 coulombs. We know that the voltage is 125 volts. The distance is given as the distance between the plates, 45.0 millimeters. So we have to change it into meters by multiplying this by 10 minus 3 meters. So that we get rid of the m in this case, and the millimeter units to change it to meters. And the last thing is about the mass of an electron. So the mass of an electron is, we have to be in kilograms, 9.109, 10 minus 31 kilograms. So we have to use all of this data, then plug them in, then solve for A. So once we do the calculations, we should end up with this equation here. And of course, after calculations, we would have the result here. So the acceleration in this case would be 3.12 10 to the 14th meter per second squared. So that's a reasonable number. The question number 2 is about the time to travel, the length of the capacitor. So since on the best way to do it is just using the x-axis, because there is no change, no acceleration in the x-axis. So this is a constant speed, acceleration equals 0. If we take this is origin, and this is the x direction, so that would be the length of the capacitor. So this distance is 70.5 millimeters. And since this is a constant speed, and the other thing that is not given is, but I'm going to give it to you right now, the Vx initial, if it is 5.88, 10 to the 6th meter per second, and we will try to use this data here. So that means we can write Vx equals distance, which is x divided by the time. That's the formula for a constant speed motion. So from here we can say that the time would be x divided by the speed Vx. And since x is 70.5 millimeters, we have to convert this. We have to convert this into meters. So you just multiply by 10 negative 3. Then we divide by the speed, which is 5.88, 10 to the 6th meter per second. And if we do these calculations, we would end up with something like the time would be so the time would be 1.20.10 times 10 to negative 8 second, which is approximately 12.0 nanosecond. On question number 3, we have to determine the distance h, because this is moving in this direction and leaving from there. So what the question says, what is this distance? Let's call this h here. So since we are just studying the vertical motions, we can say that h is 0, h0 is 0 here. And then we can say also that this is moving from the bottom to the top here. So we have h right there with an acceleration. So we can apply the this equation here, giving the h. So h equals 1.5 at squared. So since we have already calculated the time, we have calculated the accelerations, we are just applying the plug them in. Then we're gonna see this equation here. So from this equation here, we would end up with, after calculations, we would end up with h equals 0.0224 meter, which is 22.4 millimeters. If we use the millimeter units in this case. And for the last two questions, number 4, this is asking for the Vy final. So when this is moving in this direction, following the vertical motions, we can also apply the formula we used before. Vf squared equals v0 squared plus 2 acceleration distance. Our distance is h in this case. And in this case, we have assuming that there is no motions from the start on the vertical motion, so this would be 0, and that will give us the final velocity on the y direction is square root of 2ah. And when we apply all of the calculation, we use the result from the previous examples, then we would find in this case, so we have in this case when we do the calculation, the Vy after the electron is leaving the plates would be 3.74 10 to the 6th meter per second. And the last question, number 5, is asking us about the angle of velocity. So it is like this. We have here the v x, we have here Vy. So what we're gonna do is we're gonna apply applying the trigonometry properties. So since we are solving for the angle theta here, so theta would be reverse tangent of the rise over run, so that would be 3.74 10 to the 6th over that's a Vy over Vx, which is given 5.88 10 to the 6th. And solving for this angle, we would end up with 32.5 degrees. That's the that's what we have to solve. So once you understood all of these 5 different steps, always make a sketch and you will be fine. Thank you.